When we look up at the stars in the night sky, they appear as tranquil, distant points of light. However, some of these stars harbor immense power, capable of altering the universe in profound ways. Massive stars, when they reach the end of their life cycles, can explode in a dramatic event known as a supernova. These explosions rank among the most powerful events in the cosmos, temporarily outshining entire galaxies. But did you know that supernovas have also influenced Earth's history? In fact, one of these stellar detonations might have played a crucial role in the evolution of life on our planet. About 2.6 million years ago, a supernova occurred relatively close to Earth, around 150 light-years away. Scientists believe that this explosion may be linked to the mass extinction of large marine animals during that period. Fast forward to the present, and scientists are now closely monitoring a notorious star that you've likely seen in the night sky. This star is Betelgeuse, located in the Orion constellation, marking Orion's right shoulder. Recently, Betelgeuse, a red supergiant, has exhibited unusual behavior. It's been dimming frequently over the past few years, leading some to speculate that it may be on the brink of going supernova. Betelgeuse is approximately 600 light-years from Earth, meaning the light we see today from the star began its journey around 600 years ago. While the exact distance remains uncertain, it's estimated to be within that range. If Betelgeuse had already exploded in a supernova during the last 600 years, the light from that explosion would still be traveling toward us. In essence, it's conceivable that Betelgeuse could have already exploded centuries ago, and we could witness the supernova at any moment, even as soon as tomorrow. When Betelgeuse finally goes supernova, it's predicted to be the brightest one ever observed by humanity. But just how bright will it be? Will it be visible in daylight? Could it pose any danger to Earth? And why do recent observations of Betelgeuse challenge our existing knowledge of stellar physics? Recently, scientists have uncovered fascinating new information about this star, and some believe that Betelgeuse could go supernova sooner than anticipated. The countdown to this cosmic event may have already begun. Stars like Betelgeuse undergo various phases as they burn different elements in their cores. Initially, Betelgeuse, like most stars, fused hydrogen into helium, generating energy. Over millions of years, however, it exhausted its hydrogen supply and began fusing helium instead. This transition caused Betelgeuse to expand, shedding some of its mass and causing its outer layers to swell even more. Scientists have observed that Betelgeuse has already left the main sequence, the stage where stars like our Sun spend most of their lives. Currently, Betelgeuse is in the late stage of core carbon burning, fusing heavier elements in its core. As this process continues, the star becomes increasingly unstable. Eventually, when it exhausts its fuel, it will no longer be able to counteract the pull of gravity, leading to a catastrophic collapse and a spectacular supernova explosion. Recent observations indicate that Betelgeuse has already depleted a critical stellar ingredient, hydrogen. This means that helium in its core has begun to fuse into carbon. Normally, this process would cause the star to expand and slow its rotation. However, Betelgeuse is exhibiting unusual behavior. It's spinning much faster than a star at this stage of life typically would. At around 3 meters per second at its equator, Betelgeuse's rotation rate is unexpectedly high. Astronomers have long been perplexed by this unusually high spin rate. To unravel the mystery, a team of researchers led by Manos Chatsopoulos from Louisiana State University proposed a new theory about this red supergiant. They suggest that Betelgeuse may have devoured another star. According to Chatsopoulos' team, Betelgeuse was likely part of a binary star system where two stars orbit each other. These systems are common throughout the universe. In some cases, the larger star can engulf its smaller companion, absorbing its mass and energy. This transfer of energy could explain Betelgeuse's rapid spin. To test this hypothesis, the researchers ran computer simulations that modeled what would have occurred if Betelgeuse had indeed consumed a smaller star. On the other hand, another recent study posits that Betelgeuse's curious rotation might be an optical illusion created by its enormous boiling surface. What scientists had previously interpreted as rapid rotation might instead be the result of massive bubbles of gas rising and falling on Betelgeuse's surface. In 2018, observations made with the Atacama Large Millimeter Submillimeter Array in Chile indicated that Betelgeuse was spinning at approximately 11,200 miles per hour. However, recent analysis suggests that the ALMA data might not have been due to the star's rotation, but rather the movement of these massive gas bubbles. When viewed through telescopes like ALMA, which aren't as powerful as some other currently operational telescopes, the rising motion on one side of Betelgeuse could be mistaken for the star spinning toward the observer, while a falling motion could be misinterpreted as the star spinning away. Computer models show that, unlike our Sun, which is nearly a perfect sphere, Betelgeuse's surface resembles a shape-shifting blob, with gigantic globs of plasma, much larger than anything in our solar system, rising and falling like bubbles in a lava lamp. All these observations strongly suggest that Betelgeuse is nearing the end of its life. Some recent research even points to the possibility that it could explode in the near future, perhaps within tens of years. In a study published recently, scientists argue that Betelgeuse may become a supernova sooner than previously thought. The paper's authors suggest that based on the latest observations, data, and models, Betelgeuse's explosion could happen earlier than expected. However, this conclusion comes with a critical caveat. The researchers cannot precisely determine which stage of core carbon burning Betelgeuse is currently in. According to some models that match the available data, the carbon burning phase could continue for a long time. The researchers emphasize that it is impossible to determine Betelgeuse's exact evolutionary stage because surface conditions change minimally during the late stages, particularly near carbon exhaustion. While astronomers can observe the star's surface, the true story of what's happening lies deep within its core. In short, we're left with uncertainty. Betelgeuse could explode tomorrow, in a few decades, or perhaps not for another 1,000 years. But this uncertainty raises a critical question. If Betelgeuse were to go supernova soon, would it have any impact on Earth? Studies suggest that Earth would need to be within 160 light-years of a supernova for it to cause significant harm. However, Earth has experienced impacts from supernovas in its past, and scientists have discovered that some supernova explosions from over 160 light-years away have affected our planet. For instance, scientists at Lawrence Berkeley National Laboratory have reported that a supernova explosion 41,000 years ago, occurring 250 light-years away, might have contributed to the extinction of the woolly mammoth. Fortunately, Betelgeuse is far enough away that even if it were to go supernova tomorrow, it would have little effect on Earth. But this brings up another question. Are there any potentially dangerous supernovas within 250 light-years of Earth? There is indeed one star that could pose a serious threat if it were to explode: the white dwarf HR 8210, located only 150 light-years away. This star is nearing the Chandrasekhar limit, which is the maximum mass a white dwarf can attain before it explodes as a type Ia supernova. As part of a binary system, HR 8210 is slowly accumulating mass. If it reaches 1.44 solar masses, it could explode with potentially devastating consequences for Earth. Although the timeline for this event may span hundreds of millions of years, the discovery of HR 8210 indicates that there may be other potential threats lurking nearby in the cosmos.